Yeah, so this is Coffee Compiler Club. Anything to do with compilers, language runtimes, garbage collection, typing systems, language implementations in general. Open mic, ask what you want. I moderate the conversation, never had to actually moderate it. You're live, you'll go on Twitter, you'll go on YouTube within an hour or two. If you don't like that, bail out now. I think everyone's heard the spiel before. I'll probably be doing interrupts as people show up. I don't have any set agenda. I'll do my 10 seconds of what I've been doing here with AA because it was a little entertaining. I trying to merge the Hindley Milner and the flow typing in my main AA code base, and I discovered I had to redo how I was accessing primitives, so I just redid them in a big way. And I now parse AA code to go get the primitives. And then that lets me treat them like every other function call on the planet, so I don't have any special behavior there. Here, I'll throw that in. Theodore's busy doing setup here. Let me go add a line down here. This is like, how do you get the, oh, somebody has a hack to make it like be code things. I can do it roboto text, roboto mono. Yeah, it's not quite wide enough, so I need to shrink the font. Then wrap. There's a little better. So anyhow, that's really, you know, really boring AA code, except that the Java class for names are being used to do the primitives, and the math packages, it's now its own little structure. So I can throw the math package and add, you know, math.square root and stuff by just putting it in a namespace there. Okay, well, who did that and what did you do? On the doc, it got yellow background and square borders, and it looks much better.
I made a table that was 1 cell by 1 cell and then set the background to yellow.
You made a table.
Yes.
Very interesting. Okay.
I usually put code blocks in a 1 by 1 table because at least it means I can set a background that doesn't bleed to the whole document.
Right.
Aaron,
I learned that trick from HTML. Make tables of tables of tables.
You are charged to initialize the Google Docs when we start the recording.
Yeah,
the code section
link, and then you know, we wouldn't have to repost it on chat constantly. Oh, and the camera just walked in. Let me go post it on chat here.
Although I'm kind of stunned with the number of developers that work at Google that there's an insert code block widget.
Yeah, like why not? I'm on GitHub.
I'm pretty sure there's at least one programmer that works at Google.
It totally, you do code blocks. I got another guy working on AA looking for bugs now, and he found this bug. You know, what is the type of 0 + 0? So I had to go.
I would think it would be 0.
Exactly, but 0 is overloaded to int plus int, float plus float, string plus string, and the overload resolution didn't deal.
Should pick the smallest type representative.
Well, right. So 0 + 0, I happen to know is 0 because I wanted I wanted this to hold as an obvious thing, but the type resolution did not grok that all 3 of them were all 0 and that it should just report a 0 back. Instead, it threw an assert. So
yes, my instinct is that should be treated as an int 8 without good reason to do something that is more than a byte long.
Exactly.
I'm a little tempted to make it an unsigned int 8.
Right. Okay. So you're making progress. You're declaring it an int. That's a reasonable choice.
Without
my lattice land, ints and floats of small values are ambiguous. So I would claim it's an int or a float of small value. But it lost the special nilness property. Except the only other add version on it on strings would preserve the nilness property. So I don't know. I have a theory now how I'm going to deal with typing on like this kind of stuff down the road, and that I'm going to dispatch on the left argument, and nil, which is not an integer, but effectively subclasses all integer types, will be its own class, and will dispatch an add of 0 with an add of anything. It will do the 0 dispatch version, not the int or the float or the string version. And then that will do what it wants to do, which will probably say I'm always the other side, independent of what it is.
left dispatch as opposed to double dispatch?
Yeah, right. So you could talk me out
I
of
mean,
it.
I would think you would at least on something like a plus sign that takes 2 arguments. I'm surprised you don't dispatch on both.
So left dispatch is easily understood by everybody. So this gets into the what are the rules that you can glance and know. And I've stared at Julia code with double dispatch, and it's really easy to really quickly get both tricky to say what the correct answer is and to understand it as a programmer at a glance. Whereas if I only left dispatch you, then the add of, the 0 on the left is a dispatch, just like an int dispatch. He takes his right argument, does what he does with it. But everyone knows it's the 0 dispatch or the int dispatch or the float dispatch.
So the two things that pull against each other in my mind there are, on the one hand, I want the developers to be able to understand it and left dispatch is easier. And on the other hand, I want it to be that the programmer can be confident that there is instruction level parallelism here.
Oh,
and I worry with a left dispatch that you're going to turn things into essentially left fold, and you're not going to be able to get instruction level parallelism.
No, so the one is semantics and one is optimization, right? Left dispatch is semantics. Who's responsible for deciding what function got called here? And then assuming that you fold it down to some integer math, you expect the optimizer to do the right thing. Lay the fucking code out in a way that gets you better performance. Right? Well, one is semantics, one is performance.
Right, but if A plus B does not equal B plus A.
In the land of integer math, it does. In the land of float math, it does not in general. It mostly does in IEEE 74, but I think there's some corner cases. Certainly, IEEE 74 is not associative. And you just have to deal with that. And Java, in fact, went through a mode where a time where you could throw a strict math flag and he would treat floats as being associative or not, and the C2 compiler honors that flag. If you want to do x plus 0, and if you have strict math on, he'll do the plus of 0 because the answer is different if you're adding a minus 0.0 and a plus 0.0 versus anything else on the planet. You can't fold an add of a 0 unless you have some knowledge about, or you don't care about minus zeros. It's like, oh.
The sign 0 is such a bad design.
Oh, Jesus.
And it's even worse with decimal now in IEEE 754 because you have what they call cohorts. I may be using the wrong word, so it's been a couple months. But so 10.0 and 1.0 times e to the, there are different representations of the same number in the decimal. Which is something that they did avoid in the binary floating point design.
So I threw down, here's 2 to the 57th plus 1 as an integer. And 2 to the 57th is what I was trying to get with the float. I probably didn't get it quite right. And if you add them as pure integers only, you get 2 to the 58th plus 1, which is exactly representable in an int64. But the standard rules of most languages say I have a float number on the right. I'm going to promote the guy on the left to a float. It actually demotes it because he loses the plus 1. And then you add them and you get a float back, but you've lost a bit of precision because your mantissa, got chopped. And so it's just, it's not, there's not a bijection between ints and floats directly. And the standard rules of the game are, if you see a float on either side, you promote, even if it causes lossage of accuracy.
How it doesn't pick the largest type between the two?
What's larger between floats and ints? N64 and floats, what's larger? See, the number I put on the left
It depends on the result type. If the result type is a float, then it should be promoted.
You're trying to decide what the result type should be. So you can't say it depends on the result type because you're asking the question, what is the result type?
Yeah, but without much context, the compiler or the typer should decide.
Okay, without much context, the typer decides. Most languages decide saying, if I see a float, you promote it. The integer is promoted to a float. If it's 2 ints, you get an int. If one is a float, you promote the int.
I'm tempted to delay to try to figure out what the result type is, and or I have to make a compromise to lose the precision, like you said.
So you must make the compromise to lose precision in either case, because this kind of a map loses precision. I guess this one's okay if it's all ints. There's not too much further along where you can argue I'm going to lose it either way. You know, if I put a 0.01 floating value floating around that's not an integer thing on the guy on the right, I guess I can't, because that's the whole point of him. He's so big, he doesn't have any fractional bits. So he's only an integer value. Yeah, you'd have to go to overflow. Now you could go to the 2 to the 64 and you'd wrap the integer and the float would maintain something. Yeah, I claim that because it's complicated and there are a lot of weird corner cases, the correct answer is to do what everyone expects and which is obvious, which is you just fucking promote to the float. And which means for what I'm going to do, I'll probably have my integer add. If he takes a float argument on the right, he'll produce a float result. He'll promote, produce a float result. And that'll just be.
Yeah, but the intuition is to promote to a type, because when you mix it in, you expected that type to be decimal. I believe.
Yeah, yeah. You drop the link in the chat again here. Actually, I can. Can someone link to what? Oh, left dispatch.
No, yeah, it's not the Google Docs. It's someone asking what left dispatch is.
Yeah, that's actually a good thing to find a link. I'll just go ask the wiki, you know, see if it's going to do it here. Gives me left for dead, dispatch the band. Okay. Band nobody's heard of. Okay, so yeah, I got all kinds of cool suggestions for band things, but okay.
So is the question still, what is left dispatch?
Yeah, I'm gonna throw in a link to multiple dispatch in the doc because I got one of those.
I mean, left dispatch is just the C++.
Yeah, Java model.
Dispatch. It's single target, specified as, you know, pointer dot.
Yeah, Java model as well. Now, you know, Julia does multiple dispatch. And if you're doing like matrices versus floats and you have scalars and 2 and 3 and n-dimensional matrices, multiple dispatch lets you make more target choices, but it's harder to issue good code. And it becomes harder to say what any given pile of nested function calls ends up dispatching to.
Yeah, it's a massive amount of complexity just to solve the problem of A plus B.
Yeah,
and it's really it's a cute college project, but it's a very poor engineering decision. So.
Okay, fine. That's where I'm at. It can be done. Does not mean it should be done.
Right. I mean, you have a budget for ridiculous things, and they more than blew their budget on that one alone.
Yes, yeah, weirdness budget, right? I'm playing pretty hard on my weirdness budget in what I'm doing with function calls and naming spaces and stuff. I don't want to pick this.
Can I ask maybe a silly question? Just if somebody could give me the 10-second difference on multi-dispatch between just ad hoc polymorphism?
Yeah. So the idea behind polymorphism is that you basically have a, you know, potential, you know, same code, same name method, but different different options for what the compiler resolves it to. Multiple dispatch can be done at compile time or may be done at runtime, but that's not the only difference. The difference is that where it goes to look for the code is actually based on the types. So let's take a example of polymorphism on int. Let's say I have a type called int and I create 10 different add methods on it. And I say, you know, add int, add byte, add unsigned int, add float, add double, right? That's polymorphism. Multiple dispatch says, okay, I've got a left and a right. I'm going to go to the left and say, what's available on left that might match? And I'm going to go to the right and say to the right, what's available on right that might match? And then I'm going to go some global place and say, hey, in this global place, is there anyone else who has an opinion on what I should call for this? And then I'm going to organize an ANSI committee. Then I'm going to move it over to ECMA. Then I'm going to bring it back to ISO. And then
Okay,
I'm going
that
to make a
makes sense.
decision
Got
about what
it.
method to call, and
Okay.
I'll call it Julia.
Okay.
Yeah.
So it's more about like how to overload infix operations rather than just your typical, got it. Okay, understood.
The issue is, well, one of the issues, I should say, not the issue. One of the issues is that they apply it to any count of arguments. So you get an n-dimensional space to do your lookups in. Most of the space is empty.
Yeah. Okay.
So it
Thank
just
you.
becomes a nightmare to handle the general case and
Yeah,
optimize. Commonly, it's obvious.
You end up with complex rules plus ambiguity plus prioritization, plus a referee. Plus, it's just awful.
And now, who did you end up calling? It's a mess. So, yeah.
Has
Left
anyone
dispatch
ever
is the obvious answer, unfortunately, or maybe fortunately.
used Common Lisp multiple dispatch?
Ooh, no.
It's kind of interesting. It's quite powerful, but again, it's kind of that same Julia thing where it's like, well, now there's rules. You got to like go look at the rules before you can really understand.
Can you give the gist of it? The gist of it, how?
It's basically multiple dispatch. You can define a polymorphic function and say, hey, at runtime, when you run into it and you get these 4 arguments, then like you can define, hey, if the first one's an int and the third one's a record and the second one's a whatever, then do this code. Or if like the first one's an int, but the fourth one's a whatever, then do this code.
Yeah, how do they handle ambiguity?
So that's like that's the whole trick, is you got to have the rules for precedence and rules for like, because you can also have them stack. So you can have this polymorphic thing calls this one, and then a further layer, and then it backs out the layers. So it's almost like an exception handling stack. It's quite, I mean, it's really powerful. Like you can express tons of crazy stuff in it, but it's also
easy to get lost in. So it sounds like.
Yeah.
Fine.
I would say operator precedence is the most practical resolution of how to associate the operator.
Operator precedence usually means just the order of evaluation when you have a pile of operators one after another.
It's a parser. It's a parser thing usually.
Yeah, it's a parser.
Yeah.
Right.
As opposed to multiple dispatch, which is which code is this function actually going to call? For which, again, there's still precedence, but it means a different kind of precedence.
Yeah, there are languages that soft code operators and soft code operator precedence as well, which is crazy. Again, it's crazy. This was big in the 70s. I think Scheme took a shot at this as well, because then all the built-in operators, they had to pick integer numbers to represent the precedence, and then you'd have to slot your precedence in between those numbers to avoid, and then it gets worse, right? Because you could take 2 different libraries, each of which introduces their own operators with their own precedence, and now how do they fold? What's the so?
Yeah, I have a theory, because I'm playing around with this operator precedence game now, and the theory is that they're lexically scoped, not globally scoped. So if I introduce a library, he adds some new operators. It's not that you pick integer levels, you pick in between. You land at somebody else or in between 2 people. If you bring another library in, he overrides the first one in the sense that they merge lexically one after another, and you can just overwrite, except I don't let you replace an existing operator. You may add a new set of arguments or a new operator, a new class arguments handle that's unambiguous, but you can't replace integer add plus integer. That makes sense. But
Are you allowing users to define their own infix operators, or they just get to overload the fixed set of
no, you can add. So I don't have it all implemented, but the core parser doesn't fucking care. He'll take any pile of operator characters, has a very clear rule on how he parses them. He then goes and looks them up in an operator table for precedence. Well, that operator table is built at runtime, and I can totally flex it on the fly in a lexical scoping thing. So it's not far. So I threw that prim code, and you could see I'm putting multiple plus operators in there, multiple minuses, and there's a couple of them that are stacked. But I
But
could
if I
add more
want my code to
operators.
look like hashCode and be like $,
Yeah.
quote, $, now means this thing.
Yeah. You could do weird shit with operators. That's what people do them for. But I'm not going to put a lot of time on it because it's a
And
more of a niche
we've got
game.
Unicode, right? So we've got tens of thousands of new operators.
No, I wasn't ready.
Only
eating-
5 keystrokes away.
I wasn't ready to eat new operator characters from the
Come on,
Unicode lab. I guess I
set,
could.
union, set, disjoint, you know, like
Yeah,
all these
right.
beautiful.
Yeah, there's
It's
math.
you know, U plus 0, 4, 16. Come on, man.
Fine.
I'm joking. I made up the number. I have no idea.
Well, I don't know, but I set union and set intersection. There are certainly a class of people who would be all happy to have that. I don't want
think,
to
yeah.
typing it on the keyboard.
Something like IDEA, I think, can do that just automatically now. I mean, they do everything else. They
Oh,
like what you see on the screen has nothing to do with what you type, right?
The most common thing is the slash, and you name your operator, and the ID replace it with a proper Unicode.
okay.
That work well, I believe.
Okay. Never done it, so I don't know.
If you want a proper arrow, you say /arrow, and the ID will replace it with the arrow Unicode.
Right, but now the language like parses the arrow and doesn't like barf on you. That's the question. Okay, I got it in a text editor now. It's like pass through my compiler or not? Maybe. I don't have like I use a right arrow for function definition, but it's not an operator, and it doesn't land in the operator table. You can't replace it by adding a new operator. That one has to be hardwired into the parser.
So if I want to define plus for my type and my other type,
Yeah. You would say,
how do I define that function? Am
You'd
I just
say-
like plus space equal sign space and then a function?
yeah. So there's a funny game I'm playing with final assignments of functions, which is they override, they become an unresolved union that has to be resolvable at compile time and unambiguous. So I will allow you to do a final assignment of plus when there's already a final assignment of plus, and it becomes yet another overload as long as it is unambiguous. And I say I allow. The real answer, of course, is that I don't stop it, and if it's ambiguous, I'm fucked. So that's yet to be done. But the theory says you can just add another overload operator by just saying plus equals and assign a function. And it'll be lexically scoped. So once you exit that scope, no one else will see your plus operator. It'll go back to the prior version, which has 3 overloads by default. You added a 4th in this lexical scoping. When you exit that scope, it's back to the 3.
So I posted that link to the Wikipedia where they show all the various operators. And the great thing is they're ready for the next version of JavaScript when they add a 4th bar to the equals. So line for equals.
Oh, they had another bar to equal what?
Well, I'm saying it's ready for that. If you look at 2263 Unicode, U2263.
2263. Oh God. Oh my Lord.
And look at the row above that, the 225 row is just full of different equals that the JavaScript will eventually require.
The mathematical guys that they're deep into approving theorem provers are deeply they wonder they deeply care about this.
Yeah, they care a lot, and I'm like, I don't care. Don't mess up my language. But okay, don't make me read your code either.
Right, but if I had a 7-page paid limit and I couldn't publish my algorithm unless I needed to get it inside 7 pages of LaTeX, like suddenly doing it in 1 character becomes very important.
Yeah, okay,
The
fine.
reason people can write out the entire word lambda in code is because there's not a page limit.
Oh, I see. Okay. Yeah. I've seen a couple of different ways people do lambda, besides lambda and def and ref equal and
Come on, lambda,
Lambda is
the
open for
Greek
new
lambda symbol is just the coolest thing. You have to have it. Yeah.
No, I had curly brace and an arrow.
Uh.
I don't like the standard mathematical notation for lambda, which is like lambda and then one argument you're allowed, dot, and then the function body. And it's like, I like the grouping for curly braces for the function body.
Yeah, that is the hashCode notation, hashCode curly notation about the lambda calculus. The standard, the dot can be replaced, but you can have more operators, but the dot operator is the most common. Before the dot is what the lambda captures. It's dot. If it's e is the dot is before after e, then that means the lambda captures that what is before the dot.
Right.
That's
Like I said, I still prefer having curly braces to surround the capture point.
Yeah,
and I'm thinking I'm going to use dot for other things because I'm trying to do the C++ Java instance notation. So dot's going to show up anyhow. Too many dots, fine.
So you've already mentioned that you're going to have an eval. Do you think that means that you don't need get classForName?
All right, Jim, mute yourself.
Okay, clearly someone is anti get classForName.
Yeah, thank you. We got all kind of noise from you. Yeah, that's my current theory. Is if you want a classForName like effect, you're going to say eval, and then inside the body of eval, you're going to say like load and a class name or something like that, and that'll be your classForName. Pound include class name, and that's your classForName. So yeah, that's the theory. As part of the rewrite I've done this week is to get my bits and pieces of small independent code loading pulled back out of it's been kind of messed up for a while. And so it helps the testing, it helps the REPL, it'll be eval, it'll do classForName, that's part of what's been going on this last week. But yeah, is it the reason it's not going to? What's the sort of major difference? classForName takes a string and does a lookup, gives you a class.
Yeah, and a lot of analysis things, if it can figure out what that string is at compile time, is like, oh, let me just give you the class.
Right. So there's a canonical way to say, I want to get a class.
What did you mean by, Aaron, what did you mean by that? Sorry.
So certain runtimes, if you say get classForName, it will, while it's building the Java class, be like, oh, you typed get classForName, but I can tell by looking at the code that this is always going to be this class. I'm just going to replace it with an instance of that class.
But it can't. No, it replaces it with what? Dot class or something? Something dot class?
Someone says get classForName on a constant string, and you can do the lookup at compile time. You can do the lookup at compile time in certain circumstances.
But the difference is that eval can contains arbitrary code. It's
yes. So also in classForName, that is not always the case. You can do the lookup at compile time because you can have arbitrary shit floating around. So more of the question is how often can I say classForName and also allow a build tool to sort out what class I actually mean?
What I was referring to is that there's no language referenceable class constant in the Java constant pool. So you can't say, let's say you have a class called string. You can't say class C equals string.class and have it put a constant in there as an assignment, which it should do. Instead, what it does is it actually creates code that calls classForName and hides it behind some $sign.
Oh, you're talking about the reflection stuff?
Yeah. Well, string.class is a good example.
Yeah. The JIT unwinds that shit, but that's when you get around to JITting it.
You would hope so, yeah.
Very specifically for some of these, the JIT and the runtime together very specifically unwind this. This was put in a long time ago. This was mirror reflection, whatever. We had a guy got excited about it. He did a good job.
Yeah, I think reflection went in 1.1. And this feature went in.
There was a mirror, the entire reflection implementation got reset in like 1.4 with this thing where you emit bytecodes for doing the lookup and the construction for things that were more than one off. Like somebody ran through an interpreter that counted, literally, it was a mini jet. Once the interpreter hit 10 or 100 or whatever, he stopped and he emitted more bytecodes to go produce better answers. And then the JIT could eat the second set of bytecodes and directly turn them into like a fucking, string that class instance right away. So that was that, but that set of transformations to improve the quality of life for people doing heavy reflection came around in like 1.4. So the theory for the eval world is, if you write your code in some canonical way, yet to be decided what canonical way is, that all the tooling will guarantee to pick it up and eat it and do the right thing as if you wrote the class directly. And if you, and always it's like the land of JavaScript. So this is where heading down the land of where JavaScript, like module systems. Well, you got full functions with real closures. You can write a module system yourself. So people did. So there were like 3 well understood module systems for the longest time. There 1, then 2, then 3. Then ECMAScript, put their foot down, and we stuck with number 3 or whatever. There's now a well understood one. But as of when I was writing JavaScript heavily, like 2, 3, 4 years ago, not that many years ago, that you dealt with libraries that understood system 1 or system 1 and 2, but not 3, or 3 and 2 and not 1, whatever. And you had to npm, and you went to, Maven, you try to download the other, and it cross module reference this and that screw ups was ugly.
Yeah, I like the idea of doing something in the middle rather than doing something like Python that really the module system is part of the language, or something like JavaScript where it felt bolted on afterward in many different ways. You could put it in the standard library and be like, import is just a standard library function, but was part of the language from day one, so people don't go write their own unless they have a very good reason to.
But you still have eval. If you do, in fact, want to go screw around with your own, you can, but there is a canonical, this is what it looks like. Yeah, that's a good answer.
Right. If you have a good reason to need to suck code out of an Oracle database and load that, like, fine.
Yeah.
Write your own thing.
Yeah. And there'll be people who
we're back what a module means about. Jim, your microphone, your jack on the microphone.
Oh no, yeah.
So
yeah.
I'm curious, are there going to be enough operators to reproduce the C++ cast operations, or reference or pointer operations? I feel like quality of life suffered without those in reference-based languages.
Okay, so what I'm doing, and then mute yourself because you're getting horrible feedback when your mic's on. Thanks. So the way I'm doing it now is I have a pool of characters. So I'm declaring operator characters. If you string them together, it's an operator, however many and however long you want. The parser will then parse the longest possible string that makes a unique operator as its rule and how it decides to deal with stacked back-to-back operators. But otherwise, you can have an operator, any characters you want. So you have as many operators as you want. Right now, I don't do assignment with an operator. They're all purely functional. So I'll have to negotiate getting assignment operator as part of it. Does that answer the question?
Sure. Sorry, my auto level microphone is not auto leveling. So yeah, is cast operation going to exceed the capabilities of Java in terms of operator overloading?
Well, I don't know what you mean by exceed the capabilities of Java.
There is none. Okay, so if I want to cast something in Java, it's got to be that object inside the parentheses, the class name. Otherwise, I have to say
below
something.class and pass in a something.class reference to an operation to get anything that deals with that type.
So if you want to, yeah, so Java, the cast within Java syntax takes a constant class and validates the thing is that class or below or null. If you want to have a dynamic cast, then you have to make a call, which exists, that does a .class function call that will do the cast dynamically.
Yeah, Java also has C-style casts that are the converting casts.
For for primitives, for ints and floats.
For primitive types, right?
Yeah. And they're very different then. because
Oh,
one
yes.
does an unchecked bit shuffle, bit whack. The other does a check and no bit change. And also the dynamic cast has much worse performance because the static cast can be and is heavily optimized, typically down to 0 or 1 clock cycles, whereas a dynamic cast might get ugly.
But all right, so the straw man example is the casting a string as an array of characters. You could say to array or something like that, but
Okay, so no, that's not a cast. A string is a immutable pile of characters, and an array of characters is mutable. So that's not a cast. That's a defensive copy is made of the array of characters and handed to you. You get a full array copy. There's no cast.
But will we get better operator overloading of casts with AA than what Java allows you, which is strictly by method, strictly by expressing that to array method.
Okay, I would claim that the to array method is just a method call, and you could put an operator that just does a to array. Like if you wanted to have a funny double right arrow that extracted the array out of a string, you could make a prefix postfix operator that took a string on one side and returned you an array of characters on the other and did what it did under the hood, which happened to be a function call to array.
Well, at type dispatch time, maybe I have a method that accepts an array and I pass it a string. So
no, okay,
what's
so
the
that's
resolution?
different. Yeah, that's a different one. So that's one I haven't sorted out what I want to do. That's the one
what's
that
called
says,
assignment compatibility or an assignment conversion.
when am I willing to automatically, secretly under the hood, convert a type in order to make some other function work, or to make this expression work? I
When
have
I
two
declare
things.
the cast.
When
I declare the cast operator.
Okay, if you manually insert a cast, then you just honor whatever the cast says. You do that, and we're done here.
If I implement a cast operator that says, I can cast a string to an array, and then I pass it to an array method.
Yeah. So now there's what I guess the overloading jargon term we have here is you're using the word cast to mean something that will automatically convert without those specifically being asked for by the compiler. Like if
which is fair because C and C++ use the word cast to mean almost everything in the language. So I think.
Yeah, well, but okay, we got to be careful here because there's definitely casts that people.
No, what I'm saying is
manually write.
Jim's not that far out of line, although I don't like
Yeah.
the word cast, so I avoid it in general.
Okay.
Okay,
So
It's too overloaded. It means
if you convert smaller type to a larger type, let's say integer to a long, that is not a cast. Is it type coercion?
It's a cast in C.
It's implicit conversion in C++. It's implicit conversion. It's not a cast. It's not a cast.
Okay, it can be implicit. In Scala, it's implicit too. But we have to distinguish the jargon here because there are three different things that are remotely related to each other, but they're different operations.
We should just never use the word cast. That's the answer. Never use the word cast.
It is, actually. So here I wrote some code in the chat. That will fail in most languages because you don't get an implicit coercion from a float to an int, because you lose precision. On the other hand, if I do, let me do double here. Double x is equal to, like this, except they can't spell double. You'll convert that to a float freely, even as it drops precision here. Make it actually lose some bits here.
Yeah, but this is tricky.
Oh yeah, I'm not saying it's not. Okay, so that one will go and drop bits silently, and the int x equals 3.14 will not go because it's going to drop bits. Okay, so sometimes you drop bits silently and sometimes you don't. If
you don't have the type attached to the term, then there should be figure out. But if you type the int x equal 314, then you know that the operation is lossy and should allow the conversion.
Oh, there's a question from Will too. So here's another silent conversion which doesn't lose anything. And since an integer is a num as a subclass, you can just forget some of the type information you have there. That one is free, right?
But there,
and then the other direction requires an explicit cast of a thing here.
So what if I'm doing something like trying to parse IP? And I've got a buffer and I know it's an IP packet and I want to cast it to IP and look at the version number. And then based on whether I see a 4 or a 6, I'm going to cast to two different things. But I really don't want to make a copy every time.
This is a use case for a dependent type.
Yeah, I don't like the types.
I was gonna say, why do I need a dependent type? What I want to do is cast. I want to start with a thing that is essentially union IPv4, IPv6.
The cast is done at runtime.
Stop, don't say cast. Tell me what you're trying to do without using the word cast, because there's two overloads for the word cast right now.
I am trying to change the type that I understand a particular pile of bytes to be without copying the pile of bytes.
Okay. Okay, fine.
What languages that are being built today still have piles of bytes? Goodness gracious.
Well,
right, but somebody's got to parse IP.
Yeah, the network byte buffer, and in the land of Java, it's a pile of bytes. It's an array of bytes. Now you're trying to ask, is it a 6 or a 4? And somehow you ask that question. Now I want to declare it as a IP6 entity backed by this pile of bytes. And you can't do that directly in Java. You have to make a new IP6 thing and hand it the array of bytes or whatever. There's a screwing around. I think in the land of Cameron's world, you can have a pointer to a structure of data and a pointer to the class for that structure of data. So a pointer to the array of bytes and a pointer to the class for the array of bytes. And so you can silently change its type. But that's your, however the coercion is done in that zone. Yeah, reinterpreting the object representation. So there's another one. Oh, we can talk about unions. Yeah, in C and C++, you get the union thing. You can reinterpret this wad of bits. It's like in Java, you have the double as raw long bits, and raw long bits is double or whatever. Like, what's the hash value for a double? Well, the easy answer is you take the raw bits for the double. Well, there's a call for that. That in C and C++, you'd make a union and throw the bits in the float side and pull them out the inside.
Right. Yeah. But in Java, it's actually a little bit cleaner because it will clean up the bits before it shows them to you. Because it does.
Does that
mean? Because IEEE.
I don't know what cleanup means in that sentence.
Yeah, I don't know either.
IEEE 754 has, thousands of nans, for example. Java only has one. So the Java implementation, though, doesn't normalize that until you try to look at it, because otherwise every operation would be slower.
So when you say it doesn't normalize it, if I put a wad of double bits into, and I say, I'm sorry, give me the raw long bits from a double, there's no coercion, I just get the long bits. But if I take a pile of long bits, which happen to encode one of the weird nans, and I say, make it a double, you're saying he will leave it as a double of weird nan flavors until such time as you do some operation with it.
I don't know when it normalizes it. I just know that, at least from what I remember, it never lets you see any of the weirdness. It hides the weirdness.
Yeah, the weird nans float around. I mean, I implemented all the floating point games in there. I'm trying to remember, and there was something about that going around.
Yeah, it's been 20 years since I looked at it.
Right. So. Like if you took a weird nan and you did an operation, you got a nan back, but you may have kept the weird nan.
It may have kept it internally, but if you ask for the bits, will it show you the? Will it show you the?
If you ask
the 1-bit pattern,
nan, it would report true.
Right.
But I think if you did maybe if you did a double to raw long, he flipped it to a normal nan and handed it back. It could be. We had a bunch of issues you had to deal with. There are people turning around signaling, and native code would be turning on signaling nans and doing nan shit, and we had to deal with that.
Okay.
Yeah. So in the case of what I heard from Jim, though, is yet another thing, which is given a function which is declared to be a cast or an interpreting cast or whatever, it takes a thing of type A and produces a thing of type B, and it's flag special to tell the compiler is allowed to invoke this at any time to make a B from an A.
Yeah.
And then is that a technology I want to implement in the AA? And I don't know. And I kind of do, but I want to know how to do it in a way that has no ambiguity, has obvious rules with no ambiguity.
So if I'm willing to write a flag for the compiler to say it's okay to do this, is that really that much different than writing a second header for that function that says, oh, if you gave me this other type, then call the function after I coerce it?
That's a good point.
Like, I feel like I've seen the code a lot that's like, here's 9 versions of this function that each take slightly different arguments, and they all call the master one with slightly coerced arguments.
In Java, it certainly happens.
We talked about that auto conversion that we do, where you can mark a method that returns a different type as an auto.
Yeah.
And so for example, I could on string have, to array of char be an auto.
Right.
And then I could pass a string as an array of char. And that, what ends up happening is if you use this type of feature too broadly, it introduces all sorts of ambiguity. And then the compiler has to start flagging everything, which is a pain in the ass. So you want to be really, really careful. So for example, a unsigned 8-bit int, which is what we call a byte, I can assign to an int. And the way that works is that there's on byte, on uint8, there is a method that is marked as @auto. It's annotated with @auto, and it's called toInt64. But on int64, there is a toUint8, but it is not marked as auto, because if the compiler chose it for you, you would potentially lose data. So that's how we square that circle.
Okay, now how do you
Are the names magic, or do you just care about the types?
The names are not at all magic.
How do you deal with ambiguity here? You have multiple paths to go from. How many autos in a row are you allowed to stack in order to get?
So that was a fun one. So when we prototyped, we're talking 5-6 years ago, we would actually search the graph, and that was the stupidest thing ever. So we decided in reality that you never wanted to do more than one hop.
Oh, good. Oh, interesting. That's a very useful.
But we actually implemented it both ways, and we learned very quickly that the graph is freaking cool, but you really do not want to go there.
You're searching the graph at compile time, or you're searching the graph at runtime at every call?
We don't have anything at runtime.
Yeah.
So I mean, the entire idea is that everything compiles down to a chain of methods, in theory.
Yeah.
I mean, we have reflection.
But the point is that as a programmer, you couldn't understand what the hell it was doing in a broad scale. Like in individual case, you could blow the graph out manually and stare at what it was choosing and why. Oh, I get it now. But in a broad sense, you're reading code and sorting through like, what the fuck? Did it convert to what?
Well, and the bigger problem is that you have so many common types that if you convert through a common type, and there are 2 common types you convert through, they will also, so you end up with almost automatic ambiguity. If you so now if you have 2 routes, do you choose the shorter route? So do you stop searching the graph after you find the first unambiguous shortest route, or do you there were just too many questions. And it's not that it's an unanswerable question, it's that it
wasn't worth it.
It wasn't worth it.
Yeah.
I think that it's acceptable that if you specify, I want to cast all the way over to the array of bytes cast, you either, specify that distance, or you get one and only one cast, gratis.
Yeah, I like the only one gratis, and then after that you have to manually shuffle it over. That makes sense. So that might answer my question then. That sorts a bunch of problems I have where I have a ambiguity resolver now that I don't typically like. It does.
And it goes back to that question you asked the first time, what's 0 plus 0?
Yeah.
And the way that we answered that is that 0 is an int literal, which means it hasn't decided what kind of int it is. An int literal has automatic conversions to pretty much everything, except the compiler knows for compile time values what's out of bounds. So even though it's stored as an int literal in the pool, the runtime can assign it to an int, and it's already been checked at compile time, so it knows it's not out of bounds. So
Yeah.
my answer is what's 0 plus 0? Well, since int literal has the addition of an int literal as a
Yeah.
as an operator, 0 plus 0 is an int literal.
Yeah,
And I can
that is the what I was trying to say. You can if you expand the type, if you start from smaller type and continuously expand it, you don't lose information, and that is a proper way to handle it.
Right. But the reason I started with the literal concept was actually for a different problem, which is which I failed to solve. But the funny story, when I'm in a debugger and I see my values, I want to see half of them as decimal and the other half I want to see as hexadecimal. And the only way that the debugger would ever know that is if the compiler actually encoded information about what the literal form was that I was using related to that variable. So I had this elaborate scheme in my head that I was going to collect all that information, and then a debugger would automatically show me information in the format that I did it in the code. And of course, it mostly didn't work out.
Hey, Will. Yeah, we didn't get your question answered. I guess next week.
That's okay. Yeah, no, it was just for something I've been thinking about and something we could talk about whenever we have free time.
Yeah. Am I generally happy with languages targeting the JVM's backend? Yes. Am I generally happy with what the languages are that end up targeting? Sometimes I
And
like Rect and
and if
Parser.
you're the developer writing the language, are you happy with what Java's doing?
Yeah, I think that would be an interesting question to ask, like of the developers of Scala and Clojure and stuff like that. Like, are they happy with the primitives that the JVM offers?
Oh,
Well,
clearly
it's
not.
No,
It's
from
not just
the
that,
Scala.
they're also very unhappy with the fact that Java keeps adding features that conflict with
Right,
those same
yeah.
features that they added to their language already. So
Right,
Java
yeah,
looks
like
at the
they
language
want-
says,
Right.
Yeah,
And all the good
JVM
ideas from Scala and Clojure are coming into Java now too. So they're
they're
easy
incompatible.
to-
They come into Java incompatible with the way that Scala did it. So now,
right,
if you're a
and
Scala
it just takes
developer,
away
you're
their
screwed.
raison d'etre too. Yeah, to be like
yeah,
that.
but the JVM is not SVM, it's not Scala VM, it's Java VM.
Java VM, that's right. Yeah. So, all right. Well, I'm looking forward to next week, and sorry I have to leave early.
That's all right.
No problem.
Are you sure the J in JVM doesn't stand for small talk?
I
Don't know.
had nothing to do with that. That
Self.
horse left that barn before I showed up.
Perhaps self.
What was that, Matt?
Perhaps self, not small talk.
Self. Yeah, no, I came in and the son had just purchased a startup called Anamorphic, which was redoing a JIT version of Self, which was itself a redo of like Smalltalk. And so we had a Self VM that became Hotspot. It got converted to reading Java class files, and there was an initial JIT that sucked really bad, and I went through and redid the JIT, and we added multi-threading slowly over time. We added this and that over time, but it started life as a Self VM. There are little hints of that floating around the code base still. It was a
I
Craig
think the
Chambers.
big impact of Anamorphic was they wrote a whole bunch of examples of object-oriented using cats, dogs, and animals that have somehow managed to stay the example for 25
Which
years.
is the absolute worst example for object orientation that you could ever come up with. Like if you had to come
Right,
up
but if
with
the
an
name of your
example-
company is Anamorphic, like,
As you
But if
can
you
see,
had-
Cameron love this.
if you had to pick an example that would confuse everyone for the rest of their lives, right? Like if you wanted to destroy people's understanding of object orientation, the example you would pick to destroy them forever is cats, dogs, and animals. That's
How about
like-
square and rectangle?
Oh, that's the other ones.
I'm about to say square and rectangle is the other, yeah.
It's just ridiculous. But cats and dogs are worse than squares and circles. At least squares
So-
and circles.
Okay, what should have been the explanation for object orientation?
Just pick something that actually exists in code and show that.
You have to keep it super trivial to get started, and that's the problem. You always have to
It's
begin
tricky.
from
It's very
the
tricky to approach it.
stupidest, simplest thing. Go teach classes of undergrads, not grad students, starting programmers, and see what
The-
level of student you get and how you can reach them. I'm telling you that those guys got
the
a
main
tough
thing-
problem.
is you have to explain something new in the terms of something you already know. That is the main problem.
Right, and they don't know nothing. So it's interesting.
It always amazes me when I try to teach 101 and you get to the first class and you're trying to explain if and while. And people cannot understand the difference between if and while. It's like under the condition, it does the thing. Aren't these the same thing?
Yeah. So you're teaching 101, they come in having a concept of files.
Yeah, pretty much, because they've been using Word since their memories start.
Oh, that's a good point. I did a few of these undergrad level teaching things a long time ago, and I had to deal with kids who don't know what a file was, didn't know what permanent storage versus non-permanent was. Saving out of your editor was not a concept that they got. Like programming, oh my God, it was so happy when we could get to programming.
So it was weird coming from Apple to PC, because on PC you had directories, but Unix as well, right? You had directories, and Apple had no directories. Everything was in the root. In fact, there was no root because there was no directories. I mean, it was just everything was on the disk. And so this concept of directories, I just remember thinking, what the hell is this? And why would you ever want it? Right?
Why
So
would
it's
you
like,
ever want it? Well, how did they deal with
would-
namespaces? It was a flat namespace?
360K, it wasn't a problem.
Oh,
I think it was
no, fine.
153 kilobytes on the Apple II.
Well, the Apple
So-
II, no, the Apple II, yeah, I remember that. That didn't have any, yeah, sure.
Yeah, and it had a custom disk drive, because when they prototyped the disk drive, the company that made them sent Woz 10 broken ones, because they didn't want him to do a custom. They wanted him to buy the off-the-shelf one. So they sent him 10 broken ones. He got 8 of them to work with his custom driver code, which eliminated the firmware on the drive. It's a funny story.
I didn't know that. I totally believe it though.
I should
had a
look that one
neighbor-
up. That's a good story. That's a good one.
I had a friend who in high school who had a Apple II, and I had a Trash 80, and we were going back and forth on games and graphics and 6502 versus 60 or Z80 assembly and everything else.
I mean, it took a while to get a decent graphics interchange format that would work on all these different systems.
Yeah.
You like GIF? That was a long time before GIF showed up. Games were on one machine, and the graphics hardware was very different from machine to machine. Very different. Fine. Commodore PET style graphics. That was a cool thing. Character graphics. Fine. All right. Enough memory lane. What are we doing here? We're done with operator overloading. I think we sorted the just do one free conversion. We're good.
I just wanted to add, so we talked about the shapes example. So that's actually one of the things that shows up. It's called the expression problem.
Yeah.
So like you have shapes and you have operations on those shapes, like you want to calculate the area or draw it to the screen or whatever. And so the expression problem is basically, is there a way to add both more types of shapes and more types of operations, and to do both of those without well, I mean, it's usually phrased in terms of separate compilation. You want to be able to
add the link.
Separate modules that you have the original, you have a separate module adding a shape, and you have a separate module adding a function, and you want to compile a project with all three of those together.
Can you explain it in intuitive terms using AST nodes instead of shapes, if everyone?
Yeah, so I mean, I like multiple dispatch because it solves the expression problem very easily. You have multi methods for each of the shapes, and then you have the shapes as different conditions on the methods.
That's why Julia went down that path too.
Yeah.
It's same. I mean, I'm still in the zone that I don't like multiple dispatch for understanding code, which turns into you have trouble adding in both orthogonal domains. I haven't sorted out what's the right answer there, or if I'm going to just give it up.
Well, if you don't think about it too much, multi-methods work.
Exactly. That's the problem. Maybe the conversion, the auto conversion rule will solve this by letting us convert your square into a rectangle, and we'll claim that the perimeter map is close enough.
So just to kind of add in there, what Rust does for this kind of stuff is you just type like .into, and it has like a list of all the recipes to turn something into something else. So it kind of does that one hop thing, but you have to ask. It won't do it implicitly, but you can ask. And so in practice, you see a lot of code where it's just like blah, 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 something .into, and it just like, usually it's unambiguous. So it kind of figures it out mostly.
Into is different than as?
Right.
So as is for primitives, into can actually call like entire methods that may do arbitrary computation. As is like bitwise reinterpret basically, or like a numeric cast. It's something.
So
that's
into
like
is welcome
cycle.
to like go out and do DNS requests and web traffic,
Whatever.
and arbitrary things.
Whatever you want to write. Yeah, you write those. Yeah, but as is built into the language, but you can write any intos that you want.
So my question is, do you write these things where the name that you're going to is showing up somewhere, or the name that you're coming from? You got to be going to.
So it is kind of like a who should own this thing, problem.
Right.
And so actually the normal thing to do is like, if you say, here's a house and like, whatever, something should turn into a house.
In Java, integer has I take a string and I'll parse it and produce an int.
Right.
String has, I'll take this string and produce an int, and I can go from either side, and it's a kind of a mess.
Yeah.
Right. And if I, kind of we're doing this from scratch, I might think there's a conversion, an auto conversion I want to have, but if it's starting from a string place and it's going to an int place, I would claim, use the word
That's
int.
not really the expression problem, though.
No, I'm asking a different one. What's the auto conversion? Where do you put? Because I looked at Rust and I realized it felt like it had it going both ways. You could say, int could say, make it a string, and string could say, I'm taking an int. And who owns it's the same conversion. You're going from an int to a string. Who owns the rights to parse this thing? Right. And then, or you have them both, and Java ends up with them both. And none of them are auto. And I know like JavaScript for ints and strings will do autos conversions, and that gets into ugly mistakes so often. That's your one step gone bad. There's a good one. How about auto conversions? ToString I think should happen because it's so much debugging stuff, but from a string to an int, is anyone who's in favor of auto converting strings to, for instance, ints and floats? There's a that's on with the camera like, there's 3 no's, maybe 4 no's, a bunch of people being very silent.
So I tend to like toString, but I feel like there's 2 different flavors of toString. There's I need a name to be able to print something out for like a log file so I know what happened. And there's I would like a string that has all of the information that is in this object such that I could potentially serialize it in on the other side. That is for like hardcore debugging. What is this thing?
One. Yeah,
I have
small talk toString.
And I don't know how to distinguish a toString because I'm just like passing this thing to print, and a toString that's like, no, I would like a string representation of this object.
Yeah, I usually end up with 3. Actually, I have one that is serialize, deserialize, one that is pretty print something short for the log file, one that is expand out all the cleverness I can and handle every kind of broken object on the planet because I'm trying to debug it. And it pops up in the debugger and it explains the object, and it interprets all the internal fields in an easy to read way, and it handles missing fields and null things and stomped bits and whatever, and flags them appropriately, saying you should have had a type here and you don't, so you're mid construction or something else, bus, whatever. But there's some complicated version for the debugger.
It's called dump.
Yeah, right. But if I call it toString, IntelliJ will just pick it up for free. So toString then becomes not the one I dump into the log file and not the one that I use to serialize and deserialize. ToString becomes the one that I hand to the debugger.
Right. So my instinct there is that dump should be serialized out this object in a way that it could be serialized back in. So I can have dump and load.
Well, that's
And
an
that
advantage. So dump
This
being
would just be a print and be like, look, what does print do? It goes to each object and says, if you're a string, I print you. And if you're not a string, I call print on you and see if you can turn yourself into a string.
So I think that's an awful idea, and I'll except for JavaScript. And the reason is because in every other language, you actually have to support more than one format. In JavaScript, you have JSON, so the JavaScript object notation, which makes sense that JavaScript would print out JSON. But you know, most languages don't have one string format for everything. Okay, Smalltalk did, JavaScript does, but that's it. Like no other exceptions.
And I think those have been wins for both of those languages, no?
I work
Yeah,
with,
I mean, you've got the language that only 12 people ever learned how to use and is long gone, and you have the language that everyone knows how to use and is a pile of shit. Like,
right.
big wins.
I also
I
work
hate
with
it.
data
Sorry.
sets that are terabytes in size, and I had to serialize and deserialize them, for which you could not turn them into JSON. You would just die the exploity death of, blowout.
Yeah,
And
but if
in
the
fact, you wanted
default
to-
way to take an AA object and turn it into bytes is an H2O style, I'm going to be intelligent and dump this thing out, like
I don't
that
know.
seems like a killer app.
Right. I don't know. There is a thing that says I have a serializing deserializer, because my rule there was I'm moving slopping terabytes across a cluster. So I wanted compression and I wanted dense format and I wanted to still pass around strong typing info, which I pre-coded as some tiny amount of bits up front. And then I was a big payload. So deserialize and serialize. Yeah, maybe.
Yeah, if you can make an AA thing capable of passing a value to another AA thing in a dense binary format that's just part of the standard library.
It's orthogonal. It's orthogonal. So I mean, if you
but I think
it's
you're
not
right.
a language design question, it's a standard library design
It's a
question.
standard library, but it's a cool one. And I think that's a cool feature to go make happen. Absolutely. Sorry.
Hey, Cliff, just because I'm kind of curious, the H2O wire transfer format, did you ever end up kind of describing that somewhere, or is that kind of an implementation detail? Because I would actually be interested in seeing that format. I've kind of looked at some other byte formats before.
Oh, I've thrown it out in talks occasionally.
Okay. I'll figure it out then. If
Do you
it's
have a
described
link
somewhere,
to a talk
I'd like
about
to
the
see it.
H2O format?
Yeah, I'm trying to think if I actually did it. I talked about it. The format was a lot more flexible. Like we hand shook in the cluster level what your typing system was between members. And then when you threw something over the wire, you typically threw 2 bytes, which was the entire format for how many terabytes are followed, including all nested structures and everything else. And you didn't need to throw more bytes out unless you had to do a type disambiguation in the middle of a dump, which occasionally happened. So it supported it. It wasn't common though. And after that, it was, we just agreed on field dumping at the minimal size, but you compressed nils and empty fields out, and you did a bunch of array compression shit. I don't have that. No, I don't have a talk on that level of detail. The arrays all came in with specific encoding factors, special for every kind of array. I mean, internally, I already stored them as, scale shift offsetted things. Those all went over sort of directly. You dump the scale and the shift, and I'm one of these, and you send it, but it might have been run length encoding, and it might have been Huffman encoding, it might have been da da da. So you had literally 20 plus standard encodings, plus also you trimmed arrays on the ends where they had leading and trailing nulls, which is very common. And you trimmed them this way where the integers were all in a narrow range. So it was long counters computing long math, but they happen to only contain byte values. So you would trim them this way as well. I think mostly the secret was you hand shook what your Java types were, and therefore what the layout was. Once, with the first time you ever saw a Java type, we all agreed on it. So there was a cluster-wide, Paxos level handshake on these bits referred to this Java type we all understood what the Java type was. We knew how to compress it, decompress it, and that was it. Then I sent the bytes over in the compressed version, and you understood the Java types, and you decompressed it. And then after that, you did something special with arrays and some of the other encoding hacks, like this object has the following fields all null normally, and so I don't talk about it more than it was a particular encoding for that object.
Cool.
Yeah. The actual math to do the encoding was then dumped out as a Java class file. So the JIT would turn it into more or less copy bytes from a Java object to an IO byte buffer, compressing as it copied.
Nice.
Yeah, I mean, it was fast. It's as fast as I've ever seen any, the fastest serializers you ever see out there. I've benchmarked, I'm as fast as the fastest. Cryo is what at the time. As fast or faster than Cryo, and I didn't have to do anything to the classes I was passing around. The first time I passed a class around, we handshook on the class, and then it went. After that, it was just the 2 bytes.
The key is to not pass meta information, because if you don't pass it, you don't interpret it. So the more meta information you can eliminate from the serialization protocol, the faster it runs. And the ideal is that you eliminate it altogether by hard coding serializers and deserializers. And at the other extreme, you have Java serialization, and there's everything along that gradient.
Yeah. So represents too long, like show. Oh, there's the debug one though. So there's serializer.
But if I'm ever going to write the thing out to disk, I would like to be able to do it in a self-describing way that someone can find 20 years later and figure out what the object is.
Yeah, and this is where I kind of went back and forth on, and I decided that the right answer was I would list the kind of compressions I was doing per column as some kind of small name that was sensible to interpret, but leave it open-ended. And if you had a compression in a file that you hadn't seen before, you couldn't decompress that file. So this column was done with offset and shift compression with the following constants. And this column was done with run length encoding. Everyone understands the 5 or 10 of these, but then I get down to the 20th one, and this one's done with Huffman encoding, except the default nil pattern, which is never present, and run length also, and blah, 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 whatever. If you didn't know it, you can't debug it then. You can't decompress. I think that would be a reasonable format that would be mostly forward-looking and give you really good compression. I was getting better than gzip by a lot on these big data sets. It was definitely useful. Oh, you do all kind of random crap for strings too, because a lot of the string columns that have certain classes of strings only, you put a dictionary up front of the string and you put a number system in there, and then you dump and then you compress the numbers the same way you did with the regular numbers also. So it'd be stacked encoding. So it'd be fine. Never mind. We're getting down this rat hole. I don't have a talk at that level of detail. I'm sorry?
What does BWT stand for?
Be right bathroom break. Be right back.
No. Oh.
Yeah, I don't know. Yeah, hashCode, which I agree, hashCode was a screw up. Locking's a screw up as far as I'm concerned. It should not be the case that every object can lock. You want to lock, you ask for a lock, locking kind of special. You get a lock object, understands locks, not locking every object. Let me go look at my talk.
Okay, so the flip side of that is, what would you like in an object header? If the hashcode and the lock is a bad idea.
No, yeah, no hashcode, no lock. So in a garbage collected language, you need a handful of bits, 3, 4, 5, to support the GC. It's helpful. You want a class identifier somehow, which in a large Java program, you wouldn't really ever hit 1 million classes. So you need like 20 bits. So in under 32 bits, you can have the class and have some GC support. You got some spare bits. That's what we ended up at Azul. You had to have the hash code, and so we took a 64-bit header, 20 bits for the class, 31 for the hash code, because that was the limit, but you wanted all of them because you had 1 billion objects, and you had to have collisions if you only had 32 bits. And after that, you had some forwarding bits that said you had both a lock and a hash code, and now it's time to get weird. We put some more GC header bits in there so that GC could skip one of the indirections. Like it took a layout table which was the same for many objects. And it would ask the layout table bits, there were only like 5 of them. If you're one of the 31 common layouts, here's your object layout. I don't have to go parse the header.
So those bits aren't changing as the GC runs. It's not like there's a bit for marking when you do your mark and sweep.
There was a bit for,
because that can make a lot of dirty memory very quickly.
The mark and sweep bits would use the bit was on the pointer. So we robbed a pointer bit on a 64-bit pointer and mirrored it in the TLB. So that was a user mode TLB hack. It would double map with and without the bit to the same page so that user land could just read while the bit was being flipped. Unless we knew for a fact there was a fail going on, you're in a funny mode state, in which case you would take the TLB interrupt and go handle the situation. Usually clear the bit, put the object on a GC table, and then get right back. So it would be the cost of a TLB plus a CAS to put the version back in memory with the correct bit, plus a CAS onto the GC list and get back to business. So it'd be
right, but the cost I was worrying about is if you change one of these pointers by changing the low bit, have you just made the entire 4K of memory that's the pages on dirty that is now going to have to get written out, despite the fact you didn't really change anything?
If you were writing your memory to disk and you were therefore paging in a garbage collected language, you were dead
or even
already.
writing your memory out to memory. Like,
Oh, and you wouldn't write the whole page. What do you mean? You dirty to line, the cache line.
I see. So if I have some linked list, I'm not going to change all of the pointers going down the linked list.
No, if you had a linked list and they're all in the wrong age, you would. In fact, the garbage collector in the background thread would visit every member of the linked list, flipping their bits. So the GC threads trash their caches. They are horrifically cache unfriendly, but they don't care. They have no timing. They have no latency issues. So they would go grab a pointer, it would miss, and grab the next one, it would miss, and they would run 8 or 10 in parallel because they could, and it didn't matter, and they just thrashed their cache was trash. Fine. You didn't want to run your other cores on a same cluster as the GC threads are running, because we had 8 cores per L2 on an Azul hardware. But on the x86, a similar concept, sockets were screwed up. So you didn't want to run people on the same socket as an x86 GC thread. You did if you had to, obviously, but if you had enough sockets and had enough cores, you didn't do that.
So the story this takes me back to, I worked on a Django app for a while, and it, when a new web request comes in, would fork the thread and do some work and then throw away the fork. Which meant that the OS would say, oh, I'm going to make copies of all these pages, but all these pages are identical, so copy on write. I'm not actually going to make a copy of all the memory.
Oh, you're forking. Thread.
And then the GC would run, and it would change one bit on every object header, and suddenly the entire thing was dirty, and all of the copy on write memory made copies, and it tried to copy all of memory.
Yeah,
and it turned out we had to make a new rule that said disable GC before you fork, and only turn GC back on after 2 seconds. Because chances are you were going to make a whole bunch of stuff dirty and write a whole bunch of stuff out that was a total waste of time anyway, because it was all going to go away as soon as the process ended.
Full, yeah, okay. So that's we weren't doing forking garbage collected processes. That would be
okay. So your solution there is just don't fork a garbage collected process. Why would you do that?
Yeah, that's my current theory on that. I have some H2 architecture slides. I will throw a link to.
Appreciate it. Thank you.
Thank you.
They're not necessarily going into the level of detail that you want. Where'd the doc go? Let me find the doc.
That code is open source also, if we wanted to go read it, right?
Yeah. Although I claim that,
that's not the most readable code in H2.
Did horrible things to things over time. But there you go. So there's slides. The hacks you would go look at would be the FVec rules, and the parser calls the what was the name of not the weaver. The weaver was passing it around the cluster. There was the compression strategy and the decompression. It shows up in vector and FVec and frame, FVec and vec, which buried under the hood had 20 versions. Oh, that's what you're looking for next. So after vec, you go to chunks. And every chunk, there was an array, have chunk codes. Every unique chunk name was a class that supported a different compression strategy. And a chunk would have typically 1,000 to 1,000,000 elements. So that would tell you the kind of compression, and then a vector was a collection of these chunks. So you asked the question per chunk. And then the weaver was how you got the data, how it passed objects over the wire, which were often plain old Java objects, had nothing to do with the big data. You're just slopping the intermediate results of a k-means or whatever over the wire. And so
you size the chunks by count or by bytes, or
there's a heuristic.
How do you know when to stop chunking?
Yeah, right. So you parse a CSV file. The CSVs are irregularly bordered, so you can't tell how many rows will end up in a given row based on how you broke apart the CSV. So we do an initial pass where we sample the file. We decide what is the type of the columns. We tell the cluster what the type of the columns is as a whole. We hand out offsets into the CSV. Everyone starts at a different offset. They do a little screw around to get the first half line sorted out. Then they start reading lines and they finish up with the half line the other guy threw away. And whatever they got in their range was what into the chunk. As part of the heuristic that did sampling, we would guesstimate how big a pile of CSV made how big a pile of chunk. And we asked how many chunks we wanted to have. If you had a small enough data and a big enough cluster, you made your chunks pretty small, but not too small, or you too much overhead. And if you had really big data and lots of things, the chunks could get pretty big and whatever. So there's a sizing heuristic that ran around that estimated how much CSV. But then you parse CSV files, and you had a pile of longer lines in some places in the file and shorter lines in others. You got more or fewer rows and whatever. So there was some flexibility in the row sizes and the chunk sizes thereafter. The thing that worked was that the performance was largely okay as long as your range ran between that 1,000 and 1,000,000, which is a pretty big range. It's a dynamic range of 3 orders of magnitude. So it wasn't hard to hit that sweet spot. And if you're in the sweet spot, your performance is generally pretty good in terms of doing math on it. We certainly had test cases like GIF bombs and shit like that, gzip bombs that would tiny file would blow out ludicrously, make strange chunks of infinitely huge size and shit like that. You tried to tolerate as best you could, but sort of the normal case worked really well. So yeah, does that answer the question? I say 1,000 to 1,000,000, 100,000 on that order was really common. That was what we were really trying to target. Well big enough to overcome the overheads of launching a parallel thread to go do the data. So the chunks was the order of parallel execution, parallel math. So they wanted to be sized. And we had resizing too. There were times when you knew you were going to do filtering, for instance. And when you got done with the filtering, you asked, what was the, what's the chunk distribution now? And if it's too ugly, you did a resizing on the chunks, which shuffled the data, which was a kind of expensive operation. So you paid attention to them.
Yeah, it makes sense. I've seen some data sets that ended up very lopsided of things like the number of likes on a tweet, which is almost always a really tiny number, except occasionally is a really giant list of user IDs.
Right.
So it's like, oh, why is this one 6 orders of magnitude larger than the mean?
Yeah, right. You got some sort of parallel distribution going on.
So there's a funny story behind that too at Twitter, which is who's that douchebag who was really big on Twitter early on, kind of pretended to be in the tech sector.
That is not a set containing one person.
Yeah, anyway, he had glasses and was overweight. And wait, that's me too.
Get to the point, sir.
He broke Twitter because he was following over 1 million people, and over 1 million people were following him or something like that. It was like this. He was like the first line on the long tail chart.
Yeah.
And so they actually had to re-architect because of he broke their entire
parallel distribution. Yeah. Yeah.
I think it
a
was
bunch of
Gangnam
synchronous-
Style that managed to end up with a negative number of views because it was the first video to wrap around 21
Right.
billion or
Oh.
2.1 billion.
Oh, nice.
They were like, oh, drat, view counts can't be ints anymore. Good to know.
Yeah.
Or I should say int 32s.
I'd say, yeah, N64 is pretty big. Yeah, fine.
Yeah, I think it'll be a while before the first person overflows int 64 with views.
Yeah, right. There's some old popular videos. I wonder if they're still getting views. Cows with guns was up there forever.
Squirrels on skateboards, man.
That one I haven't seen, sorry. Although Charlie the Unicorn, my kids were so in love with Charlie the Unicorn. Oh, so depressing, ludicrous, and huge counts of views. Way over
yeah.
your but not 2 billion. I don't know if they had 2
That video was as much fun as mountains of candy.
Yeah, Candy Mountain. All right, I have to go ask Charlie the Unicorn. There he is, Candy Mountain, Charlie the Unicorn, Candy Mountain. Okay, I have to go look at views. No, don't do that. Okay, only 37 million views on Charlie the Unicorn of the first one as opposed to the Candy Mountain one. I have to look now because it popped up as a separate one.
I will say though, as you start having more and more users, you do find yourself in pathological corner cases that you're just like. The first time we ran across someone who noticed that tweet IDs were kind of predictable in the way they were given out.
Oh.
So used the API to make a tweet, which was a reply to itself by guessing the tweet ID that we were going to assign the tweet.
Ooh.
We had some code
Yeah.
that really didn't like cycles in the tree of this is a retweet of is a retweet of.
Absolutely. Absolutely. Oh,
Yeah,
excellent.
but the design for the
Turns out
IDs,
people assumed that was a tree. False.
the algorithm the Twitter was Snowflake, if I'm not mistaken. The design is to be distributed to large amount of machines to generate IDs without synchronizing themselves. That is the main goal.
Text compression strategy from Jim BWT. It's fine. Yeah, when we were doing text things, it was usually words or it was fixed known names like San Francisco. So all the San Franciscos you threw into a dictionary and you just put a small number on them and then you did the number compression. Or it was a pile of words that were being worded at because you're doing natural language or whatever, you're doing word to vec kind of shit. In which case, yeah, we usually end up with a dictionary anyhow. I think ultimately if it was random text, we literally took the gzipped version of the random text strings and just piled it in as a random pile of text. Nothing
But
huge.
text in web APIs is particularly repetitive.
Oh.
Like the chances that you hear back from some server and the phrase okay and failed shows up 1,000 times each.
Yeah, right. No, if I have random piles of text and I want to compress and there's no interpretation to be done, gzip will pick up on the okay and fail because it does the Huffman encoding on the okay and fail. It's fine.
That's why it works.
Yeah.
The most common cases first.
And so gzip covers the sins of I just have a wad of uninterpreted text. If I have interpretation on the text, I want to group people by cities as I'm computing their salaries. I'm grouping them by zip code because I'm going to compute the salary per zip code as a machine learning heuristic for how I can tell how much money I'm going to loan them or something, shit like that. Then you wanted the city name to turn into a number, which was indexed as a separate thing, and that turned into a column in a ML algorithm and whatever.
The moment you want to search the string for some processing, you have to invent a scheme before front to compress.
So if I'm doing that kind of compression, like San Francisco's are all in one digit and Houston's and New York's or whatever, we did all the searches on the dictionary bits. And in some cases, we pre-cooked the dictionary bit search because we knew you were going to ask this question a bunch. And so he could just tell you, you did a table lookup. If it's number 5, oh, that was San Francisco. And the answer for searching for capitals in San Francisco is it's not the capital of California, whatever the fuck you were doing. Yeah, we did those things too. Not so often. Yeah, when you manually asked for, like the baked in built-in H2O did some stuff, and then people, certain kind of algorithms did other things. And you could go ask for, give me the dictionary, pre-cook this math calculation in the dictionary. Now I can do a dictionary lookup on across the cluster without actually looking at the dictionary. Yeah. Okay, well, here we are. It's 11:30. We're kind of at a quiet spot here.
I've occasionally seen people introduce a new type of string that has some cooked offsets so that you don't have to iterate from the beginning of the string every time doing the whole Unicode decoding thing.
Oh, if you're doing like a web URL.
If you have like a 4 GB UTF-8 encoded Unicode string.
Oh, well, there's your
It's
problem.
really nice to have offsets to be like, here is where each 64K character starts.
Yeah, there's your problem. Don't do that, and life will get a lot better.
Yeah, you've advocated a few times to use ASCII instead of UTF-8 where possible.
I sat down at Julia and I tried to run TCPH queries at high speed. And the #1 bottleneck was go find the following word, burnished, embered, copper, steel, whatever, in a string where it was UTF-8 because Julia only did UTF-8. So there was an outer loop over characters. I'm doing a Boyer-Moore algorithm, stupidest thing on the planet. And there was an inner secret loop they didn't tell you about that they did for every character. And so your Boyer-Moore algorithm was 10 times slower than the equivalent Java code. And it was
but you have to get character at is linear.
Oh my God, it was a fucking
nightmare. If I want the 2017th character, I have to start from the beginning to count the characters.
And the second inner loop was completely useless because, of course, this is TCPH query from the 60s and 70s. There ain't no Unicode in there. So the answer was I had to go make Julia eat a pile of bytes and behave string-like, but not ever declare it a string or accidentally touch a string object where he would happily auto-convert it to a string and therefore thereafter only do Unicode shit on it. And so it was a giant pain in the neck to work around having only Unicode strings as a default. Like I badly wanted to say, you know, this is not a Unicode string, quit being Unicode-y. Like Python, you have like U string and C string and regular string, and okay, great. And C string for compatibility with C guys and U string for the Unicode guys. And I just have a pile of bytes, give me a string. Oh, there's a thumbs up, absolutely. That's where I'm headed at here. If you want Unicode because you like to hurt yourself, okay. You don't have a billion of them and you don't care about performance, okay, not a problem. You got a billion of them, you want it to run yesterday instead of today or tomorrow, whatever, you care. Give me an easy way to not have to fight it off. That was a feature in the language that I couldn't turn off. That was a pain in the neck. Too much help. Sorry. All right, I'm done ranting on Unicode.
The other one that's nice is to be able to ask questions that distinguish bytes from characters. Sometimes what I actually want is not the millionth character of the array, but I'd be perfectly happy to say, index into this array by 1,000,000 bytes, and then give me the beginning of the next character after 1,000,000 bytes into the array.
This is only a Unicode issue. If I have
specifically a UTF-8 issue.
Or UTF-8, yeah. If I have a string of 1 billion ASCII characters, then like I ate a log file. I went to Splunk and ate a terabyte log file. It's 1 billion trillion bytes. It is not anybody's Unicode or UTF-8. Now I want to just deal with it like it's a UTF-8 and the millionth element's just an array index. If I have to interpret the billion, then I've made a mistake in my data structure choices, but now I'm living with the mistake. But you're right, now you want to have an iterator that matches character counts versus byte offsets and iterates them both as you walk through the array. And the iterator has this complicated state that's not 1 entry, it's 2. And it can track character count versus byte offsets.
But because you can pre-cook what would the user ask. If there is a way to infuse the loops, counting characters or bytes, there be maybe a better soft spot, but you can do one or the other. because you can do both. You can't do both efficiently, at least in my opinion.
As soon as you have to count them separately, you added a lot of overhead, which if you have very little other overhead in your scanning loop, like a Boyer-Moore would have very little overhead, then you added most of your overhead was dealing with the UTF-8 versus not. If you have a ton of other overheads going on, then you don't care UTF-8 or not because you're drowning other overheads. But my experience with string parsing, I either didn't care at all because it's small, or I cared immensely because it was big, and then UTF-8 was like a no, don't do that.
So if I have essentially arrays of variable sized things in my language as a construct, it might be nice to have slices over that also, so that I could either hand you an array of variable sized things or something that says, hey,
right,
I'm a slice over this underlying storage. Here's my pointer to where I'm at, and here's my counter to where I'm at.
As soon as you say I have an array of variable sized things, you immediately bring forth a nested set of iterators. This is what H2O does. The chunks are variable sized, but I would iterate over all the rows. But I had starting points at different row numbers based on where the chunks were. So there was an index array that we all agreed on, handshaked around the cluster. That was the starting point for every row number in every chunk. And then you went to a chunk and asked his compression strategy how to get the row within the chunk. But now you had a nested structure. It was complicated and had to deal. And I think that's the right answer. It's a pay-as-you-go model. None of this is baked in. If you want to have a nested iterator or a joined paired iterators like the bytes Unicode offsets because you have variable length structures, you have to ask for it. You have to pay as you go. Unicode can be in the library as a standard thing, but it's a thing that is not the default.
Right. I would say you want iterator of variable sized things to be part of the standard library so that different packages can pass these kinds of things to each other in a somewhat consistent way.
So you start with first having a canonical iterator that does a good job in sort of mini contexts. And then you could ask, can I extend that to handle this variable size thing? So as I'm Python and I want to iterate over collections where sometimes the iteration gives me the key, sometimes the value, sometimes both, sometimes the index of an array, sometimes it's the index and the value, whatever. There's a bunch of flavors of iterator you can get out. It's pretty flexible. Presumably it can be optimized well. When I reach that point in AA, then the next point is, can I extend this kind of iterator and a collection which can be iterated over to support what I want to say would be a compressed version of variable size things. Because the other way to do, variable size things in a collection is you just have point to the head of each one, like a Java array points to Persians. They don't back-to-back Persians in a big array. They have an array of pointers to the objects.
But there's no reason you couldn't do both and say, here is my large contiguous block of memory that's got all my objects in it.
Yeah.
And by the way, here's my index over it if you need to indirect through to get directly to something.
Right.
Essentially, you'll consume a lot of memory doing that, but
it's a data structure choice. It kind of makes some amount of sense. You want to put strong typing on it as well. And then you also end up with like garbage collection issues because you have a giant big array and you're sharing internal portions out of it or not, or you're copying them as they go or whatever. So there's something to do there with, storage format for big things that makes sense to be compressed, especially if you have tiny objects with headers or killing you. You want to strip the header and jam them in an array. Variable size things are difficult in a big array, but they make sense if you have that kind of a compression going on. You have a big array, it's hard to move for the garbage collector, and you're handing out parts on the inside of the array out. And as soon as you hand out parts, you have embedded garbage collection issues, which has its own, like it really whacks on the garbage collector hard, this handout embedded pointers. So there's a bunch of things that stew together there that you have to think about really hard before you vote in on that one. My first cut impression would be no language support. If you build one, you built one, and then you get a big fat array and you have interpretation at byte offsets. Totally works for piles of Unicode, totally works for piles of IPv4 versus 6 versus whatever. Won't work for Persian objects because you can't have embedded Persian objects inside of an array, or you're not doing any object embedding. If you're going to do object embedding, that's the one that invokes the huge grief from the GC. And actually a fair amount of grief from the runtime supported as well.
Is that specific to variable size, or no matter how you do that, you're going to make the GC sad that you've got a big object that was allocated at once and needs to be freed at once?
If you're embedding objects and you hand out embedded pointers, that's the problem. So if I have a pile of persons, variable sized or not, I put them in a big array, I hand out the 17th person as a pointer to some code that's doing person-y things. I now have an embedded pointer into my array that points to the root of a person that's buried inside the bigger array. Now I have an embedded object problem. If I move the array, I have to find all the embedded pointers. So the same problem is do object inlining everywhere. Somebody says I have a person and they have a city and I want to embed the city string inside the person. I don't want to have a pointer to a string object that's different. I want to have it embedded inside. I want to have embedded inside, you know, other object things. Now I hand out these embedded internal objects. Now it comes time to go do a moving garbage collector. Go find the base object from an embedded guy. I'm looking at a city string. Well, it turns out it was embedded in a person, which was embedded in a giant array. So the garbage collector has to know the giant array as a whole is live. Okay, how does he even tell that? He's got a string. What's the reverse pointer to get him back to the base of the big array? Well, he's not dragging that around, or you blew up, you didn't have a string, you had a string with a back pointer. Something's going on there that lets you do that efficiently. And that's the issue you have. So the common
so
thing,
I either end up with fat pointers everywhere that have both a pointer and an offset,
you end up with fat pointers everywhere.
or I end up with some big table where I'm registering all of these things and deregistering all these things, in which case
Yeah,
I'm
the
now
table
swapping that into
dies
memory all the time.
The table dies as soon as I have too many of them. I can have some small set of objects that are embedded in that get copied as embedded things a bazillion places, or I have some really enormous object that has a bunch of embeddings, whatever. The table will kill you. I claim you do fat pointers, but now it's just that it hits your runtime everywhere. It's your performance all across the board. Every register got halved because it takes 2 registers to carry a pointer around. So that's a significant performance impact to do embedded pointers. And it's significant engineering complexity. So that's the reason to like fight on that one. What I have done and will continue to do is put wrappers where I make a tiny object, which is the embedded fat pointer that points to the base of the array on the offset and does all the interpretation on the fly. So I do a string-like thing where I'm parsing strings out of the terabyte log file where I just take a NIO buffer of bytes. I have a string object that's a stir, it has all the string API, but it points to the base of the NIO buffer and it points to the offset in the NIO buffer. And then I do string-like things as long as I understand that it has a timer at ages when the NIO buffer flips, the string is toast and I have to reset it. But then I don't need to copy the string data anywhere and I have embedded strings. And that's how I think you should do that. And I made a fat pointer that had an API of a string-like or a person-like or whatever. I think that's the way to do that one.
How do you do the guarding for when the IO buffer flips? Do you have a generation counter, or?
No. In this case,
that seems like a lot of burden to put on the programmer to say,
it's
simply know when the IO buffer flips.
It's malloc and free. It's the same effort as malloc and free. When I end the loop that's processing a raw line out of the NIO buffer, and I declare all those stir objects to be reusable on the next pass of the loop, and they're declared dead, and I roll the NIO buffer if needed. And if I got to half of a line, I flipped the half a line down and then rolled more NIO bits in, and then life went on again. But the stir objects were manually lifetimed as if essentially malloc and free. So that's the complexity with doing that. It's performance. It's huge performance. There's like 5x gains, like big integer factor speedups here, over doing the obvious thing in Java where you just make strings out of your NIO buffers and do string-like things and let the garbage go. You drown in bandwidth overheads, kills you. So for 5x speedups, it's worth screwing around some. And now you're doing malloc and free, but only in a small piece of code. I have to do malloc and free but only in this much code, 2 pages of code. Take your, eat your poison, however you want to eat your poison. That was a class I taught last year when I was doing rocket school. I was teaching that class. Hand out a 2 gig log file, fintech log file data. Go process this log file and go tell me how many products are being traded. What was the average value? What was the average size of the trade? What was this? What was that? Bunch of math. Okay, the math is totally trivial, completely free. All your time was sucking in the data. And if you started out by saying, buffered read line and string split that line on the columns and then do things, you lost. As soon as you hit buffered read line, you're dead. So you had to start from not buffered read line. And that's the head wrapping you had to do on that one. The math was free. You don't care about all the math in the world. Standard deviations and average and sums and max and mins and all free. No. Get the data, that's expensive. Buffered read line, wrong way to get the data.
I mean, I think that's the mental model for most web services today, is that the computation is essentially free compared to just getting the data to one spot.
Okay. Yeah, my experience with people doing web services, and maybe I just have narrow solution here, narrow exposure base, is that they don't know that there's a memory bandwidth problem and they don't know how to work around it if they do. So their first step is to do something bad in terms of memory bandwidth footprint. And then they're lost already. And the first thing I do when I do these performance hacks for people, which I still do kind of often, is I start looking at what they're making, where it's coming, where it's going, and almost always there's a giant bandwidth stupid thing, and I fix the giant bandwidth by do a little tiny malloc free hack, or do a little interning hack, or do one of these little stupid things, and they get 5x speedups. It's like sadly reliable. Oh, here you go. Somebody's doing this on a network card. Yeah, of course. Yeah, sure. Why the hell are you copying giant piles of bytes from the network to the CPU memory? The first thing the CPU memory wants to do is look for, hey, is it this particular fill I'm trying to fill, or I'm going to cancel, or whatever. He's going to read 5 bytes, throw the rest away, and say, cancel, get me out of here. It's a high frequency trader.
The earlier, the better. Mm-hmm.
So what's Scoble? I've seen that name before. That was the Twitter guy. Oh, God. Yeah, I recognize that name. There you go. That's so sad. Fine.
Yeah, it was bothering me that I couldn't remember. Not that I want to remember.
It's all good. All right. Now I'm going to claim we're getting close to 2 hours again.
Yeah.
All right. If there's nothing else going on, then I'm going to declare end of meeting. The good one
by
again.
The way, funny story, by the way. Keith did a pull request. I got a pull request from Keith this morning. He's not on the call today.
Excellent.
About?
He was fixing something I wrote.
Yeah. I've had only a handful of pull requests, and they're all been docs.
Yeah.
0 + 0 wasn't a pull request. It was so is this supposed to be well defined?
So it turns out that cut and paste has downsides.
Excellent. Good to know. All right. Until we meet again.
Okay. Bye, guys.
Thank you.